Welcome to another Fenestration Canada podcast.
This podcast is a presentation of Quanex Building Products. For more than 30 years, Super Spacer Tri-Seal from Quanex Building Products has been the ideal warm edge spacer solution for commercial and architectural glass. With its unique triple seal design, Tri-Seal provides structural strength, durability, and outstanding thermal performance in the most demanding applications. Learn more at quanex.com. And now it's technical time with UL.
Hello and welcome to Technical Time with UL, where we talk about the ongoings of the window and door industry and how UL can help enable safety and sustainability of your products. My name's Ryan Harper and I'm your host for this session today. Joining me is Benjamin Holt, a senior account executive with our UL Environment and Sustainability team. How you doing, Ben?
Good, Ryan. Thanks for having me today.
No problem. So, Ben, you and I have had many conversations, and today more than ever, social and environmental sustainability is really good for business. There's a research report conducted by the Nielsen company that showed that 2/3 of global consumers are willing to pay more for products and services that come from companies that are committed to a positive social and environmental impact. The problem, though, is that the companies are finding that these environmental processes give them some key challenges in that they can't really effectively communicate that sustainability effort to their stakeholders and the public in general. So I wanted to get your opinion today, Ben, why are companies experiencing challenges in what we call green marketing?
That's a great question. And one of the main challenges we see is green product marketing, is anything but black and white. There are a growing number of eco-labels that has made it difficult to differentiate from a consumer perspective between products that are genuinely environmentally preferable and those that aren't.
So obviously we can support that initiatives. How do we help differentiate the good from the bad?
Right. So yeah, UL offers certifications that ensure that products live up to their environmental claims and are able to differentiate against those that are quote unquote greenwashing, which is a term that refers to products that make environmental claims without proof. So as an example, a greenwashing claim could be something as simply as putting environmentally safe or 100% organic on the product or the website, brochures, whatever. These are blanket statements that don't have any supportive information that can be validated or verified.
So what's an example then of something that UL would validate against for the fenestration industry?
So some of the relevant claims that the fenestration industry focuses on or could focus on recycled content, meaning that the products are manufactured with materials that contain post-consumer recycled content. Mold resistance, which means that products are manufactured with materials that are resistant to developing mold. And probably the most common or popular claim would be zero waste to landfill, which is basically it's a claim that proves that a facility is consistently diverting materials to land or away from landfill.
Okay. So once a product has been taken their claim and it's been validated by UL, what can that fenestration manufacturer now do with that claim?
Sure. Once the claim has been validated, manufacturers are able to use the UL Green Badge on their product packaging, marketing materials, website, etc. Basically, this badge communicates to customers and prospects that the products have been tested and or verified by a neutral third party and independently validated to have been manufactured and or performed in accordance with its specific environmental claim.
Great. Good information there. Thanks, Ben. Thanks for your time. I really appreciate having you.
Excellent. My pleasure.
And thanks to you for listening. To learn more about how environmental claim validations can help your product, please visit canada.ul.com/fencan, that's FENCAN, or you can email Benjamin directly at benjamin.holt@ul.com. Till next time, thank you very much and enjoy the show.
This This is Tech Talks, live conversations about the regulatory environment with Al Yagalis.
Okay, so hi everyone. We're now live on Zoom and on YouTube for this Tech Talks Season 2, Episode 5, I think. So I just want to thank again Quanex as a sponsor of this show and UL. So Al, I understand today that we're going to be in the UL theme. So if you want to introduce us to your guest.
Yes, our guest today is Haya Sogradi. She's the engineering leader at the UL Building Envelope Performance Testing Lab in Toronto. Haya is a longtime member of the Fenestration Canada Technical Services Committee, and she is currently the co-chair of that committee with Dave Goldsmith. So Haya, welcome to the show.
Thank you for having me.
We're very happy to have you on our program today. And our subject today, of course, is NAFS testing. Specifically, NAFS testing questions that our callers may have based on their experiences in testing products at labs, or maybe they're new to lab testing and they have questions about the process. So definitely we welcome participants in the show. We've got 21 at the moment online, which is great. You're welcome to ask questions. Feel free to raise your hand or use the chat function, and Stefan will let us know.
Yeah, with the Q&A ideally.
With the Q&A?
Yeah, so we can show it on screen. But
good.
Yeah.
Right. So yes, so we'll be happy to take your questions through the call. But we'll start with just getting a little bit to know you a little bit, Haya. I see you graduated from Ryerson with a Bachelor of Architectural Science, specializing in building science. Tell us about your journey from there to the testing industry.
So I graduated from Ryerson University with a Bachelor in Building Science, major in Building Science, Bachelor of Architecture. I started working at a test lab campus in Toronto for a few years, getting more into, which I found it quite interesting and quite intriguing, the whole testing and innovation process that the industry was going through at the time. And through that, I got also very familiar and involved into energy performance rating on the products, and start participating in different standard meetings. From working at campus, then I moved to Element at or Exoba at the time, or known as Element at the moment. Was there for a couple of years, and then from there I joined UL in the Toronto division to start a new building envelope test lab. I've been here since 2018.
That's very interesting. Now, because it's a building envelope performance test lab, what do you test there besides windows?
So we basically, the lab here is more focused toward different stages of testing. So from product testing, such as fenestration products, we also focused largely into project mock-up testing. So, considering products from the, testing them from the a stage of manufacturing a stage to how it would actually perform when it's installed with the site conditions, and considering how it's tied to the existing infrastructure, and some of the different testing criteria that you may want to consider when you're looking at an entire facade of a building, rather than just the individual products and rating it on its own parameters.
Right. Okay.
We also do offer field testing services, which then continues in the same methodology and looking at it from the perspective of when the product is actually installed on site and how is it performed at that stage.
Okay, so your lab also then does the field testing of
We
windows,
do offer field testing,
windows, right?
yes, and then of course material testing, yes.
Yeah. So I guess you basically have ended up specializing in windows and fenestration as the building envelope area of choice.
Yeah. Testing to me, it was very intriguing from the beginning, just because it is very unique. Products are special in the sense of what we are receiving to test, and to consider that some of the larger mock-ups that we are testing, and considering some of the projects that it's actually installed eventually in somewhere within North America, to be part of that, it is interesting.
So you test for projects outside of Canada as well?
Yes, we do.
Okay, that's pretty interesting. And tell us about your current role at UL. Are you closer to the product testing and the customer, or more of a management supervisory level?
At the moment, I do both. So I am close with the customer's relationship, and also I do the managerial role as well.
Okay.
At the moment, yeah.
Okay. So I was thinking back to the early days of the NAFS standard, when it was introduced in the 2010 National Building Code, and around 2012, I think people were starting to test their products. And it came as quite a shock to us as manufacturers. At the time, I was working for a window and door manufacturer, and we were faced with this new terminology: performance class, performance grade, and significant changes to the testing, mainly to the amount of testing required. We were used to testing a fixed window, a casement window, a sliding window, and a patio door, and you were done. And you get this NAFS standard, and all of a sudden, it's not enough just to test those items, to the gateway size or the largest size you sell. You need to think about mullions and everything else. So this was quite a shock to us, but was NAFS a surprise to test labs as well?
Well, NAFS standard, or the North American Harmonizer standard, had been around since 2002. So test labs, we had been familiar with the standard. We had been testing products. There was the 2002 version, 05 version, and also 08 version of the standard. And 08 version of the NAFS standard was the version that was adapted into the code. So there were manufacturers, and the labs especially were familiar with the previous versions. There were manufacturers that they were trying to try to test to these standards previously, but at the time, you're absolutely correct. In 2010, when the code changed, that was the time that a lot of us, we started to talk about this newer standard that was not a A440 standard anymore. That wasn't just the ABC levels anymore. And we were looking at different ratings. The different method of testing and consideration that we were looking at.
Right, yeah. Now, we're seeing more and more imported products from Europe and even from China coming into the country. Are you finding that the importers of these products are coming to test labs to test their products in Canada?
Yes, a lot of times, they come in and they're hoping, and they consider that, based on the EU standards that they have tested their products to, that they could get their product could be equivalent to our standards in North America, and they can basically get equivalency and test and sell their products in North America. But majority of the time, unfortunately, there is a gap between the European standards and the North American standards. And majority of them, they face not only they realize that they have to retest or test their product again for our environment, just because our standards are different, our requirements are different. And sometimes they even have to consider our climate and the product that they are selling into.
So in other words, they come to realize you can't just make an equivalency between the European testing and the North American testing. You actually have to test to the North American standards in order to qualify a product for North America.
Yeah,
And
it's for
specific-
example, one example of it is water penetration test. The method of testing in European standard, the way that they consider and they perform the water penetration test, it's completely different than our ASTM standards. So they have to actually retest completely.
Right. Yeah. Yeah. And I think the structural testing is very similar in Europe, isn't it?
In some ways it can be similar depending on the standard. In some of their standard, it asks for a cyclic structural pressure testing, whereas in our standards we look at it or the method of the ASTM that we have adapted in NAFS, it looks at it as a static pressure rather than the cyclic pressure.
Right. Yeah. Yeah. Well, that's good to know. Now, I know when from personal experience that sometimes things go wrong at the lab, right? You make your plans, you install the window in a test buck, and you're quite excited about how it's going to turn out, and sometimes you get surprises, things I didn't think about. You know,
Yep.
What are some of the things you've seen that can lead to premature failures of a product during testing? You know, and and are there ways to prevent that?
I think one thing I can touch based on and talk about it here is to consider the sample that you want to send to a test lab. Consider it as not a sample that needs to go to the test lab. Consider it as a sample that is your that is part of the production line that you want to sell it in it's going to be sold in the market or it's going to be installed in the market. You want to make sure there's a resemblance, because all the standards that you are testing the products into, they all require us as part of the report to do indicate of the product or report on the product that we tested as what we've seen in the lab, what we have tested in the lab. So you want to make sure that yes, there is a due diligence that goes against the product that will be tested in the lab. We all understand that, but you don't want to take it to a level that is not a product that it would be actually go through the production. And it's
in other words, you shouldn't be testing a product that is materially different.
Performance different.
Exactly. That uses different gaskets or different screws or different components than you normally sell, right?
Yeah.
Yeah. But do you sometimes see failures in the lab that could have been prevented by some planning? I'm thinking of things where, I wanted to test our product with our standard anchoring method, and we had already tested the anchors independently in the lab and were confident of them. But, we sent a huge window to the lab and and never actually did any calculations to check the anchor against the design pressure we were hoping for. We wanted like a PG 60 design pressure. And, the product anchors blew out at PG 40.
Yeah.
and it's kind of like a head slap, like, check the anchors before you, put it together. I mean, so there's a certain amount of planning that should go into it. And I'm wondering if from experience, there are things that people should have as a kind of a checklist before they finalize their test specimen and bring it to the lab.
We've seen, for example, some of the things that we see is wrong drainage locations, that during the production, by mistake, a drain hole was punched into a cavity that it was not supposed to have drainage in it. So it's a double check of the system before you send it to make sure that it's done correctly. Sometimes we've seen also different type of or different thickness of glass used than the PG levels that was required for the testing. And it's just that one level of consideration to consider to know what type of glass we have used, or what type of, as you mentioned, the anchoring point that it is taken into account, or the sizes of the anchorage, things like that. These are some of the common practices that we see. Sometimes even a wrong type of silicone that it's dissolved by just a water penetration testing. So these are some of the things that we want, we all should consider before sending the sample to the lab.
Okay, no water soluble sealants, right?
Yes.
But it's interesting you mentioned the glass strength issue. So what does NAFS say about the strength of the glass in the test specimen?
So NAFS standard does reference ASTM standard in regard to the glass thickness and the PG performance grade of the product. And we have to make sure the product that is tested is for that strength or lower. So, and you do want to make sure also that if you are testing the product with anneal glass, then the product is good for anneal type of glass. Laminated or tempered will not be covered, and vice versa. So when you are selecting your sample for the testing, you really have to be cautious about these things. So it's sometimes when we say this, some people think that it's an extra level of consideration, or they're not sure about some of the glass calculation that they have to do. But it's the similar mentality as when you are enforcing a product. If you reinforce your product and you test it and you get a PG level, well, if you don't reinforce it, you will not meet the same performance grade. So you have to look at a glass as part of the same categories. That when you're choosing your glass, you have to be cognizant of what performance grade you want to meet, and that then you consider that the glass that you're using, it's good for that performance grade.
Right. So in other words, I think NAF says that you have to test with the weakest glass that will achieve the performance grade you're testing for, right?
Yes. And at the same time, exactly. So which means that the glass has to be meeting that performance grade.
Right. And not more than that, right?
Exactly.
Yeah. In other words, the standard doesn't want you to use glass that is stronger than it needs to be, because that could improve your performance grade.
Yes.
And so you don't want to get the benefit of a higher performance grade that depends on the glass, right?
Yeah. And yeah. And you have to always, and this goes back against what we talked earlier, that the test labs are required to report on the product that they've tested. So if they report on a 5 mil glass thickness, well, then that product was based on a 5 mil glass, and the report is based on the 5 mil glass thickness.
But the NAF standard is not testing the glass; it's just testing
the entire product.
Right.
But we do report on the specimen that we tested.
Right. Yeah. But I mean, if you're testing a large window, you maybe needed 5 millimeter glass. But if you're selling a production unit at a smaller size, you don't need 5 millimeter glass.
No, you can't go lower.
Whatever the strength requirement is for the project, right?
Yes.
Yeah. But I think your point was, if you're testing with stronger glass, so maybe you're testing with 6 millimeter tempered, and it's stronger than you need, then the report say that the product is only qualified with tempered glass?
The report will not say it's only qualified for that type of glass, but the report description indicates that this product at this size sample was tested based on 6 mil tempered glass.
I see. Does the report indicate that this was stronger than needed for the performance grade?
No, we don't make that judgment call.
I see. I know that when I was testing products, I believe the lab we worked with actually said that that's what they would do. That they would say that they would comment that the glass was stronger than needed for the performance grade in that situation.
So the report that we provide it is based on the description of a product that we've tested in the lab. So if we prior and during our inspection and then prior to the testing, if we see something unusual, we would bring it up. We would talk to our customers to ensure that they understand that this is something that you're seeing. Now, if they choose to continue to test it in that parameter because of their design requirements, then the report only indicates the sample, the product that we tested.
Right, yeah. And in terms of choosing the design pressure for your test, when a manufacturer comes to the lab, does the lab provide any guidance or engineering services to help determine a starting point, or is it up to the manufacturer to rely on an engineer or past performance to determine where to begin?
So typically, it's a conversation that we are having. It's a two-way conversation that we have with the with our clients and our customers, depending on what their need. We do provide certain resources for them to feel confidence on the test, the performance grade that they want to achieve. But ultimately, it's our client's choice on what performance grade they want to meet.
Right, okay. And in terms of deciding on the anchoring method to attach the product to the test fixture, the NAFS standard clearly says it's not primarily intended on testing the anchoring method or the installation method of the window. But there are kind of the real world installation methods that we're all familiar with. And sometimes, of course, in the lab, we see, other installation methods used. What are the pros and cons for a manufacturer to consider if they're testing with more fasteners or supports than would be the case in a real world installation?
So, the issues or the concerns that they would face not using the proper installation then on site, or the location of the installation, or molding the samples together. If they tested in the same one system in the lab and then they installed on site in another system, they could have water penetration issues, they could have torsion issues or structural issues on site. Yes, you are absolutely correct. The NAFS standard has clear indication that we do not measure the performance of the anchoring system, but we do report on it.
Mm-hmm. Yeah.
And the reports do clearly indicate the method that the sample was installed into the rough opening of the buck.
Right.
Manufacturers, sometimes they have their own procedures of how to install it. We do have the A440.4 standard and 0.6 standard that indicates how the samples have to be installed, and guides the manufacturers on how to install their products into their buck and to their rough opening. That could assist them with what is actually required for site installation.
Yeah, in other words, the installation standards
Yeah.
Provide guidance on that subject. Yeah. Any questions from our callers, Steph?
Yes, we actually have a couple questions. So we could start with Mark asking, what type of freedom do you have in position of window type in a composite window system for labeling? Example, if you test a fixed sash over an awning with horizontal T-Mullion, can you label the window with the awning on top of the fixed sash, reverse the position, or do you need a separate test report or an engineering report?
So you could do you could follow multiple options there. Okay. You could do the engineering evaluation. You could do the equivalency, but I would recommend you, if you have those options, and if you do offer it that way, talk to your lab, let them see in advance, let them see the differences of the product systems and the elevation of your product combination or composite system that you have, and for them to make sure they cover it properly for you, so you don't have to consider all the options down the later on not being covered with the test report that you have already.
Okay.
So in other words, if you want to test a combination fixed awning, ask the lab, should I test the awning above and fixed below, or fixed above and awning below? In other words,
or let them know that you offer it this way, and let them know this is the design of my Mullion section at this level based on this, and they can then assist you correctly to say whether based on your design, based on the profile that you have, whether engineering calculation could assist you, or what option testing could cover the other option.
Okay.
Good. So we have Terry asking, in-lab installation of products is often not necessarily representative of a real-world installation. I have concerns as labs simply say they reference the install details as tested, but hold no responsibility for the performance of the real-world installed product performance. Do you think there needs to be more oversight of how manufacturers install for lab testing, ensuring they use same or similar as their product are installed in the field?
I think whether it is the continuing this conversation with the manufacturers to get everybody understand and see the difference or the pros and cons of not installing the window properly or the product properly into the box versus the reality of how the product is installed on site. Our NAFS standard, our guideline has certain requirements, and we can go obey by it as much as we can. But I think mainly would be a education that we need to offer to the industry, constant education that we need to offer to the industry to make everybody understand the cons and pros of what you are mentioning, which is absolutely a valid point that we've seen quite a lot of it.
Okay. Al, do you have anything to add to that?
I think the question is, I think what Terry's asking is, does the lab, should the lab play a role in sort of policing whether the method is realistic or not? And I think that might be outside the scope of the lab.
Yeah, exactly what you mentioned. You have to we have to kind of understand that the lab, the way that a product may install from one project to the other project, the installation may vary. So it is not, it becomes out of a scope of a test lab for a product that they're testing as a performance of an individual product to evaluate all those procedures per se.
Okay.
I think there was a technical interpretation that was issued from the JDMG on test specimen installation that made the NAFS, the technical interpretation was less permissive than the NAFS standard. And I'll make a note of that. It's something that we might want to look into at another Tech Talks.
Okay.
Because I think it did make, I wrote a blog post on the NAFS in Canada blog where I covered a number of JDMG technical interpretations, and that was one of them. It seemed to clean up the language on NAFS testing providing guidance in addition to what was in the NAFS standard itself. And maybe we'll look at that in a future show.
Okay. Let's move to the next question. We have Mark asking, how do you determine what glass thickness and strength you should use during testing? Is there a table to refer to, or do you need a lab to provide a recommendation on the weakest glass to use at a certain size?
So there is ASTM and AMA standards that NAFS reference in regard to calculating the glass thickness. That is also referenced in the code as well. That they can be used in order to calculate the glass. In NAFS also does explain a little bit on how to calculate it. You can use engineering calculation to actually consider the glass thickness that you need to use.
Okay.
Is that a service that the lab could provide? In other words, if a manufacturer is saying, here's what I'm planning to test at the lab, you have an idea of what performance grade they're aiming for, would the lab help them to design the glass? Or would they consult an engineer to do that?
They would consult an engineer for that.
Okay. Okay.
Yeah.
Okay, so we just have a comment here. So Terry's saying, I suspect there are many high performance results that are not realistic in the real world. So anyone care to comment on this one? No one will.
Well, I think Terry is right. I mean, there are, we've all seen how windows perform under a test, especially double glazed windows. They can move quite a bit under positive and negative pressure. So you've got the frames rotating and so on. And there's the potential that by locking the frame in place into the text fixture in a way that is very, very rigid, but you could not really do it in the real world. In a real installation, nobody would let you install a window that way. Terry's point is that potentially a product may achieve a higher performance grade when it's anchored in an unrealistic way. And that if it was anchored in the way that it would be in the real world, it might not achieve that same level of performance, right?
Yeah.
So
he has an absolute, and I agree completely. There are products that, based on the anchoring method, it's that it could not represent the reality of what's on sites.
Okay.
So it's definitely a bit of a problem. I would say it's probably a higher risk in large buildings.
Yeah.
But in large buildings, there's usually some engineering oversight, and there's often some mock-up testing involved. And so, there's at the minimum, there's at least usually some engineering evaluation of the anchoring method at the project sizes and at the project pressures. So there is some oversight there in large buildings. But in small buildings, in Part 9 buildings, there isn't that level of oversight. Fortunately, we generally don't have those same wind pressures at the small buildings. But of course, that could change on the Pacific coast or the Atlantic coast, where essentially, you're in open terrain, and sometimes you're experiencing the equivalent of wind speed up over hills, and that's where you could end up with problems for sure.
And I have to give it to our industry. Over the years, we have seen a change in more of a change toward it. People are much more now, majority of manufacturers are much more cognizant about their anchoring points, whether they have their own procedure or whether they follow the installation standards that we have, or whether they consider those things when they're installing the samples. There were years prior that we would have seen unprecedented amount of installation screws or brackets or angles along or shimming in around the specimen, where we don't see as much anymore. So I think it's as we discuss it as an industry more about it, and we talk more and more about it, hopefully we will see more changes in the near future.
Yeah, that's good to know. It's good to know that there's a trend in that direction, you know. I know when I was testing products for the company I worked for, we developed our own strap anchor system. And so we wanted to test that system so that people would have confidence in it. You know, we were concerned that people would look at our anchors and say, oh, those are too flimsy. They would never work.
Yeah.
And so we made a point of, pre-engineering and pre-testing it, but we always did our NAFS testing with that anchor system.
Right.
So that there would never be any question about whether that anchor system was adequate. And I think, especially if you're using a non-standard anchor system, like a strap anchor, I think it's helpful to be able to show that it actually does handle the loads at your recommended spacing, so that, people will be confident, especially if you get involved in a market where architects or engineers are evaluating your product for a larger building. They're going to want to know that your anchoring method is really going to work, and this is where, qualifying it in the lab with your NAFS test can be a strong marketing point to sort of take away the doubts or questions they have about your anchoring method. So,
you're absolutely correct. And we see it that sometimes they even consider a different method of installation to just make sure that they validate different options.
Oh, really? So some companies test several anchoring methods?
Yes.
Okay. Yeah. Oh, that's good to know. Any other questions there, Steph?
No, so that's it for now. We don't have questions on YouTube either for now. So maybe you could let us know what you're planning to do for next week.
Oh, so no. We're still not finished.
You still have questions?
I still have a few more questions for Haya.
I didn't know that. Okay, so... But, whenever you want to, maybe now is a good time since I brought it up, but, we want to encourage our listeners and viewers here to, send questions in advance, but also put questions in the Q&A here. And in the next few weeks, we're going to focus a little bit more on questions, but I'll let you explain that to them later. So you can go ahead with your questions.
Sure. So recently on Tech Talks, we've been talking about products with mullions and about the Mullion assembly designator. Do you find that your clients are aware of the Mullion assembly designator when they come to the lab, if they're testing products with mullions?
Yes, and if sometimes they're not, that's a conversation that we have.
Okay.
Prior to in the test planning stages, we have that conversation. We make sure that they understand that they know that this is one of the requirements for them.
And do you report automatically the Mullion assembly designator when you're testing a product with mullions, or does the manufacturer have to ask to report the Mullion assembly designator? For example, take a simple example. We're testing a casement fixed window with an integral mullion.
Yep.
So that test report would give you a performance class and grade for the casement window, for the fixed window, and for the combination assembly, right? And it would also give you a performance class and grade for the mullion assembly too, right?
Yes.
So would the Mullion assembly designator be reported separately in the report, or would the manufacturer have to ask for it to be reported?
No, it really goes back based on the conversations that we have with the manufacturers. If they have a rating on their individual products previously, then the report will not cover the individual product. It will be just a combination unit, and the report will just have the rating for the mold assembly. If they do not have the rating on the individual product and the individual products were not tested to the minimum requirements of the standard, then we make sure we cover those, and the report does have the Mullion rating as well.
So you could potentially have a single test specimen that gave you, ratings for the individual casement window, the individual fixed window,
yes,
and the mullion,
Yes.
all out of one test, right?
Yes.
And you would have 3 different products with 3 different, actually 4 different products, because you would have the casement, the fixed, the mullion, and the overall assembly.
Yes.
You would have 4 sets of ratings potentially for that product if it was your initial test of the casement and the fixed window.
You could do that, but you have to consider then you have to, the sizes of that sample may not be realistic.
Yes.
Depending on the performance class and the rating it requires to achieve.
Right. Yeah. But if the framing system was strong enough to support that, then potentially you could do that, right?
Yes.
Yeah. So we've also talked about AMA 450. We had Tarek Eloua a few weeks ago telling us about AMA 450 and how the test labs can generate a lot more value from that test. For example, if we did test that window with the mullion, now with AMA 450, we can provide a span and tributary width tables for the mullion, in that window, for example. And then we also talked about the option 2 and 3, a simple beam test or engineering to qualify mullions.
Yep.
We also talked about comparative analysis methods last week, such as AMA 2502 and WDMA IS11. So my question is, at the labs that you've worked at, did you find manufacturers knew about these, about AMA 450 and comparative analysis? Did they know about it when they came to the lab, and or not? And also, did the labs offer these services to the clients, or do you wait for clients to ask for these things?
So it's a really of a evolvement of our industry throughout the years. There was a time that by just testing to the previous standards like A440 standards, those requirements or considering those things was not as much as what we do, how we use them today. So, and as the implementation of NAFS came into the code, the first stage that we saw was the individual products, and then majority of the manufacturers try to first consider the testing of their individual products before before considering combinations. So recently we've seen in the last few years, we've seen more interest in it, more involvement into it. Majority of the test labs, they do offer some method of using AMA 450, whether it is the engineering calculations that they do internally, whether it is working with external engineers that they work with to create those calculations, and then they do the additional testing in the lab. But majority of the time, it's a conversation that we are having with the manufacturers. Some manufacturers may already consider those things, and when they come to the lab, then it's a different conversation than the lab would have with them. It's a matter of, okay, I have all this information, this is the method you want to go, versus sometimes you have to educate the manufacturers about considering all their options, giving us all the information in order for us to see which path works the best for them and gives them the best results that they need at the end of the day.
Then that brings up a good point, is that some manufacturers just come to the lab with the minimum, right? What's the least amount of testing I need to do? I don't want to spend much money.
Right.
But sometimes it's helpful, I think. Don't you think it's helpful for them to come with an idea of, here's my whole product line. Here's all the different things I do.
Yeah.
I can't afford to test everything.
Yeah.
I know that I could spend the rest of my life paying for testing. I don't want to do that, right?
Yeah.
I have a business to run. But does it help you if you know all the options of the system, if you know all the different mullion types, the different ways they mold the products together, the sizes of the different components? If the manufacturer comes with all this information, can the lab help them to come up with a test plan that fits their budget, but also helps them to test the best things to test initially so that they can use things like comparative analysis or AMA 450 later to expand the coverage of their product line. Can you talk about that?
Tremendously. Informing the lab of all the systems, cladding methods that you have, glazing, whether you have dual and triple glaze, whether you offer those options, whether you offer different Mullion system, different reinforcement, different, whether it is internal reinforcement or external reinforcement, all that information, if it's provided to the lab at the beginning, they can help out. Yes, it may sometimes the price that they give out or the project seem to be quite large, but then we can work out phases. Rather than, we've been involved in projects where we are not informed completely of the systems that are offered, and by the end of the testing, our clients are facing with much more higher costs that they expected, just because we weren't aware of all the systems and all the products that they offer. If we know these things, then as you mentioned, that we have different systems, AMA 450, requirements that we can use, or grouping requirements, or that we can consider and use in order to group certain things or calculate certain things. So you don't have, there is less of a testing, or there could be a combination of things that could be covered under each other, rather than the lab doesn't realize these things, and the system has to be now tested in different variation, just because the original variation that was tested does not cover the latest option that they have.
So that's a really good point. This is where the manufacturer might only have a budget for 3 tests.
Yeah.
But if they just come to you with 3 windows, or if they say, but here's the whole product line, here's the big picture, here's what, then they might still only afford 3 tests, but they might make better choices.
Yes.
About the 3 things they're going to test.
Exactly.
They might find that with the grouping rules of AMA 450, that, with those 3 tests, they might be able to qualify 6, 7, 8 options.
Yeah.
You know what I mean? Where otherwise, if they didn't know that, for the 3 tests, you might only be covering those 3 options, and you might have very limited flexibility.
Yeah.
But if you knew, in other words, the lab can help you to get the most value long-term, because yes, test only 3 now, but then but if you also later have money for a little more testing, you could cover all of these options, and you could cover all of those options. And now you have an intelligent test plan.
Exactly.
Now you know how little you've covered with your 3 test specimens, but you also know what your next steps will be.
Exactly.
And you also know the kind of conversations you can have with the lab to make sure that every step you take gets you more value.
Yeah.
So that you don't necessarily have to spend more money than you wanted to on testing, but at least you know what you've covered and what more you can cover with another test or 2.
Yeah.
Because you might run into a project where you need to do another test for a project, and you could take that project test cost, and instead of just getting a project window tested that doesn't qualify anything else, you might be able to configure it to also solve a few more of your testing challenges, right?
Exactly. It's I 100% absolutely agreeing with what you're saying. If you I would suggest to all the manufacturers always that come in with a set of your drawings, if you can come in with the complete and be open to the lab of all the systems and products you have. Yes, you mentioned about 3 testing that you can do. They can also we can plan out the testing process for them. We can put it into different phases for them. Phase 1 could be this type of product testing. Phase 2 could be this. Phase 3 could be something else. And by the end of it, then their entire system could be evaluated, rather than just focusing on what is in hand, not considering all their options, and the difficulties that they may face later on. So if there's even limitation in the cost of how much we can spend on testing, by creating these different phases, the cost can be allocated properly into the testing and get the most benefit out of the testing that you're doing, rather than spending too much money into testing.
Right. Because in the long run, I know manufacturers that have acquired, 20, 30 NAFS tests.
Yeah.
But it's kind of a hodgepodge. We tested this, then we forgot, then we tested that, and then a project came up and we tested that. But,
Yeah.
And then you look at all these test reports, and you say, my God, there's so much duplication here.
Exactly.
So much overlap between the tests.
Exactly.
And I've, for one manufacturer, I was scratching my head. You spent so much money on NAFS testing, but you didn't spend it wisely. You could have, if you had a plan for how to proceed with this, you could have spent less money testing, a lot less money testing, and covered more of your product line. And you wouldn't be coming to me now asking to help you to sort out through all your test reports and try to get more value out of them.
Yeah.
This is the conversation you should have had with a test lab first, so that you could have planned your testing in a rational way, and you would have spent less money in the long run, and you would have had a game plan, where you're going next.
Exactly.
What you've covered, stay within your budget. You don't have to blow your budget right away, but at least what you've covered and what your options are going forward. And I think anybody who's, bringing a new product line to the lab, because start having those kind of conversations, because in the long run, you will save money and be much more, make much better decisions about your investment in testing.
Absolutely.
We do have another question here, if you want, Al. I could.
Yes, of course.
So we have Mark asking, if we want to know what windows are equivalent for labeling, example, the fixed sash over awning or awning over fixed sash, what documentation is required? Do the labs need to report it in the test report? Do they need an official engineering report from the lab to show equivalencies? Or is it up to the manufacturer to determine what they can label based on their interpretations of conversations with the lab?
What a great question. Haya, that's yours.
So a lot of time when that information with the drawings and everything is provided to the lab, a lot of times what labs can do, they can issue equivalency letter or equivalency statement in the report. So then they can use that as for the labeling process. So then the rating that they get in the report, that they see in the report for the type A of the product that was tested versus type B of the product that tested, can be covered by that rating now. Sometimes by just issuing an amendment to the original report, then they can also use that as a cover. So it depends on the information that is provided to the lab and the analysis that the lab does in order to how to cover those different options with the test report that was done.
But this is just another example of how bringing these questions, bringing all the options of your product line, the different elevations of your of the products you offer, you can now have a much more intelligent conversation with the lab and make better choices and know what the lab can do later to help you and to get to more value out of it. So great question, Mark, and
absolutely,
you're making the case for the value that this provides.
Yeah.
Any other questions, Steph?
No, that was the last one for now.
Okay. Well, I've got a couple of last questions for Haya. And this is, I'm no longer in the manufacturing world, but these are things that I would want to ask a lab if I was developing a test program for a new product line. And I guess we've already covered some of these, but I'll just repeat the questions that I would be asking. Sure. Can your lab engineers help me to determine the optimal test sizes for my fixed products to maximize my options for comparative analysis of individual unit products?
So,
in other words, should I be testing a taller, narrower fixed window or a horizontal fixed window, in terms of sizes, if I wanted to be able to take advantage of comparative analysis, right? What should my sizes be that I can cover most options?
Right.
That kind of a question.
So that type of question, yes, the labs can assist if they, goes back to that idea of if we know those configuration by testing the smaller size, larger size, and configuring doing the comparative analysis in between. Yes, the labs can assist that way.
Okay. And we've already, I guess my next question is, can your engineer review my complete product offering to determine how to qualify the majority of my products with a minimum number of tests using AMA 450, Mullion assembly ratings, and comparative analysis?
Yes.
And I guess I didn't look at my list here, but I had this question prepared yesterday, but we've already covered it. But it's basically worth just reiterating that yes,
exactly.
Value here, right?
To just give you an example, I had a few cases where combination of AMA 450, we had the projects that they were over 100 different type of combination assemblies, and we drop it down to testing 3 or 4 of them based on using the AMA 450 calculation, and then doing the grouping of different systems, and by just doing 4 or 5 different testing, they covered the entire 100 different assemblies.
There you go. Yeah, you see that's the smart way to prepare for NAFS testing is to have those conversations. And I didn't realize the numbers were so dramatic, right?
Yeah, it could get
hundreds of combinations, covered under 4 or 5 tests.
It could,
And so that's definitely the smart way to approach it. Now, the last question has to do with not testing to the minimum, but testing for bragging rights. So I know that many manufacturers want to do the minimum amount of money testing to save money. But let's say you're a company with a really well-designed, high-performance product line. You can get higher design pressure ratings because you have reinforcement options, internal, external, maybe, right? That's what the company I used to work for had. And we wanted to test our products to the highest level, not to the minimum. And one of the problems we had when we tested at American test labs, they would always test to the minimum requirement of the standard. And I would be talking to the lab manager before the test saying, look, I want to test everything to the highest performance grade, the highest water test pressure, the highest air infiltration and exfiltration level. And but if I wasn't at the lab standing behind the technician would test to the performance, they would stop testing water at the performance grade at 15% of design pressure. They wouldn't test, because in the United States, there's no incentive to test beyond the minimum.
Yeah.
And so really, when you want to do that, so some questions came to my mind. If I wanted to prove just how great my product was, I would like to test beyond the minimum requirements. And so let's say I have a high performance product line, let's say a CW product line, and I think it's capable of satisfying all the AW class requirements. And in the case of my company's product at the time, we couldn't pass the sash leaf torsion test. And the sash leaf torsion test meant if we couldn't pass that test, it could not be an AW class product. But if we still wanted to test it to AW class air leakage, right? So normally we test at 75 pascals, but for AW class, you test your air leakage at 300 pascals, right?
Yeah.
So could I optionally test my product at 300 pascals as well as 75 and report that value separately from the performance class and performance grade in the test report?
So one thing, the differences between R2CW performance class under NAFS, we could, considering the size of the product, considering different things can be covered. Considering, for example, if you for if you test the LC, but you want to consider your design, the deflection under your design load, whereas for LC product is not considered as a lower 175, but a CW product it is. So we could consider those things. We could report on those things if it's based on the conversation that we have with the manufacturers. They consider it. Typically from CW to AW, that's something that is not as easy anymore. Just because AW performance requirements are a set of specific guidelines that we have for AW testing, as far as meeting the AMA 910 requirements when it comes to the performance of the product before and after life cycling testing. And it's not just the higher air pressure anymore.
Let me clarify my question.
Sorry. Yeah.
So I know that my product will never have the AW class.
Yes.
Right?
Yes.
But so I'm not trying to qualify it to both CW and AW. I know that the test report will only say CW because I can't pass one of the gateway tests, which is sash leaf torsion. If I can't do that, it will never be AW.
Yeah.
But the question is, can I still test to the AW water penetration requirements, right? Can I test my CW product to under ASTM 547 and 331?
You could.
Right? Can I test my air leakage at 75 and 300?
Yeah.
Right? Can I test and report it in the test report, of course, separately? It's like an optional test, right? So sort of the first or second page of the report will not contain those numbers, but later in the report it'll be there, right?
Yeah, so but that's the information that you have to provide to the test.
Yes.
Up front.
Of course, we discuss it up front. Then I want to test to the highest forced entry resistance level in ASTM 588. So the minimum is grade 10, but I want grade 40, right? So you can test to that. Can I decide to say, and also test lab, in addition to my CW test report with this extra information, I would like to test my CW product to AMA 910. Mm-hmm. To do all the same tests in AMA 910. Is there any problem with getting my CW product tested under AMA 910 just to show that it does have that level of durability?
We could do as a separate set of testing.
It would be a separate test.
Yeah,
right?
To just show the levels of performance that this product has met to different performance classes. We could absolutely, that's something that the lab can do without per se designating it or referencing a standard or indicating that it was tested in accordance to a standard. Yes.
So in other words, there would be no problem. I could take my CW product and I could get an AMA 910 report for it, and it would just say that the product passed AMA 910.
It could have a basically designation on how just the testing that was performed.
Exactly. It would just be a 910 test report. It was nothing about performance class, right?
Exactly.
Yes. Okay. So in other words, I think this is sometimes a missed opportunity for companies that have superior performing products, is they don't think about testing to higher than minimum levels to demonstrate, that a product actually has the ability to be very durable, even if it's in the CW class. It may still be a very durable product. It may still pass AMA 910. And so, this is the kind of thing that I think the manufacturers of products that have superior performance capabilities, they could take advantage of being able to demonstrate those superior properties under our test standards.
Yeah, just be cognizant that AMA 910 does reference or refer back to NAFS standard, which means that product has to meet the NAFS standard requirements. So
it has to be a NAFS tested product to actually be able to be tested under 910. Right.
Yeah.
Yeah.
So we could say that we could follow that test procedure, and we could just basically say pass or fail on it.
Yeah. Right. Exactly.
Yeah.
Yeah. Okay. Good. Well, this is it. This is for the keeners out there. This is for the the ones that want to have bragging rights for having a superior product. I think.
Yes.
I think there are some companies that might be interested in knowing that it's possible to do that. That you're not limited to the minimum performance criteria of a performance class, in terms of demonstrating your product's capabilities. So,
but and again, that goes back to the conversation that we had earlier. Talk to your test lab, engage them in that conversation, see what other options, how they can assist, how they can help you out.
Right. Yeah. Okay. Well, if there's no more questions, Steph, I'd say we're done.
Good. So there's no more question for now.
So thank you very much, Haya, for taking this time with us. We've had about an hour together here. I hope that this will be helpful to folks, who missed our show today, but they'll be able to see it on YouTube. Yeah. And I think you've been very helpful to us today in really helping our members to appreciate the best value they can get for their NAFS testing and how to do it. So thank you for being with us today.
Thank you for having me. And it's always a pleasure serving the industry.
Great.
Thanks a lot. I just want to thank again, UL for sure, and Quanex as sponsors of Tech Talks, and see you next week. Bye-bye.
Thanks, everyone.
Bye-bye.
You are a member and want to be part of the live recording of Tech Talks? Easy. Visit fenestrationcanada.ca and sign up for the next show.